So the first key point is 1 factorial to 4 factorial. Here I will write number of zeros at the end. Number of zeros at the end. Number of zeros at the end. It is also called as trailing zeros. 1 factorial to 4 factorial. It does not contain any multiple of 5. So it is 0. It is 0. 5 factorial to 9 factorial. From 5 factorial to 9 factorial, there is one multiple of 5. So here it is 1. Listen carefully, sir. From 10 factorial to 14 factorial, there are two multiples of 10. 5 ones are 5, it is present. 5 twos are 10, it is present. It is 2. From 15 factorial to 19 factorial, it is 3. What are that 3? 15 is there, 10 is there, 5 is there. 15 is 5 into 3, 10 is 5 into 2, and 5 is 5 into 1. Now see, 20 factorial till 24 factorial. 24 factorial. 20, which all numbers are there? 20 it is there, 15 it is there, 10 it is there, 5 it is there. So it is 4. Now, very, very important observation. Very, very important observation. Now listen carefully, sir. Very, very important observation. Suppose if I take 25 factorial. 25 factorial. 25 factorial is 25 into 24 and so on, 20 and so on, 15 and so on, 10 and so on, 5 and so on up to 1. Listen carefully. Factorial definition is product of all natural numbers from 1 to n. From 1 to 25 I wrote. Now if you observe the number of zeros, here there is 5 ones. Now number highest power of 5. 5 ones are 5. 1 5. 10 it is. 5 twos are 10. Second 5. 15 it is. 5 threes are 15. Third 5. 20 it is. 5 fours are 20. Here it is 5 into 5. Here 2 powers of 5 are there. Here 2 powers of 5. Here 1 power of 5. 1 power of 5. 1 power of 5. 1 power of 5. How many we got? 1, 2, 3, 4. 4 plus 2, 6. How many zeros we will get? From 25 factorial till 29 factorial. How many zeros I got? 6. Sir, you are taking the power of 5, but you are writing number of zeros at the end. When you are multiplying the numbers, suppose for example, 10 factorial it is there. So it is 10 into, 9 into, 7 into, 6 into, 5 into, 4 into, 3 into 2 into 1. This is the factorial definition. Product of all natural numbers from 1 to 10. Product of all natural numbers from 1 to 10. Now see here. It is how many powers of 2 are there? Some powers 3. Some powers 5. Highest powers we discussed. 2, 3, 5, 7. 7 there is 1 power. 5. 5 ones are 5 twos are. 5 square. 3. 3 ones are 3 twos are 3. It is 4. Already we discussed in highest power. 3 threes are 9. 3 ones are 3. 3 plus 1, 4. So it is 2 fives are 10. 2 twos are 4. 2 ones are 2. 5 plus 2 plus 1, it is 8. So 10 factorial is 2 power 8 into 3 power 4 into 5 square. Number of zeros at the end. Number of zeros at the end. Or number of trailing zeros. Very, very important, sir. First 10-15 minutes of conversation is extremely important. Number of trailing zeros. What do you mean by trailing zeros? Add zeros to the tail of that number. Number of zeros at the end. Now if you see here, listen carefully. 10 power 1, it is 10. It is 1 0. 10 square, it is 100. It is 2 zeros. 10 cube, it is 1000. How many zeros? 3 zeros. Number of zeros at the end is always the highest power of 10. Highest power of 10. So 10 can be written as 2 into 5 power k. So this can be written as 2 into 5 power 2 into 2 power 6 into 3 power 4 into 7 power 1. 10 square. 10 square will have 2 zeros at the end. 2 zeros at the end. Now if you observe, power of 2's are very high compared to the power of 5. Power of 2's are very high compared to the power of 5. So in a factorial problems, instead of taking 2 and 5, it is enough to take power of 5. Only in factorial problems, if I want the number of zeros at the end, it is always the highest power of 5. Anyway, in trailing zeros, I will take a class where I will prove that it is not always highest power of 5. It is only valid for a factorial problems. Listen carefully to this line. Only for a factorial problems, number of zeros at the end is highest power of 5. If it is not in a factorial format, it could be highest power of 2, which we will discuss in detail in our next class. So please write down this point, sir. Number of zeros at the end, it is the highest power of 5. Number of zeros at the end, it is the highest power of 5. Only for factorial problems. Only for factorial problems. Only for factorial based number of zeros at the end, it is equivalent to highest power of 5. Again, I am repeating, there are some important observations. From 1 to 4 factorial, there are no multiples of 5, 0. From 5 to 9, only one multiple of 5, 1. From 10 to 14, 10 it is there, 5 it is there, 2. From 15 to 19, 15 it is there, 10 it is there, 5 it is there, 3. 20 to 24, 20 it is there, 15 it is there, 10 it is there, 5 it is there, 4. From 25, here 5 ones are, 5 twos are, 5 threes are, 5 fours are, 5 square, extra 2 powers of 5 are there. So 4 plus 2, it is 6. That means the question can be like this. Question can be like this. N factorial ends with 5 zeros. N factorial ends with 5 zeros. How many values n can take? N factorial ends with 5 zeros. How many values n can take? According to this calculation, 0, 1, 2, 3, 4. After 4, direct jump to 6. Because I am getting 25 factorial. 25, it is 5 square. So there is a jump of 2. There is a jump of 2. How many values? No value of n. No value of n. No value of n will have 5 zeros at the end. I hope the idea it is clear. Very simple foundation level question. Sir, what if instead of 5 it is 25, it is 35, it is 45, it is 65. How to find out the values? It's a very simple observation. 0, 1, 2, 3, 4. From 4 directly there is a jump to 6. There are no 5 zeros at the end. So answer is no value for n. Number of zeros at the end. Number of zeros at the end. It is always the highest power of 10. Number of zeros at the end. It is always the highest power of 10. 10 is a composite number. A composite number can be written as a product of prime bases 2 and 5. Only for factorial based problems, number of zeros at the end, it is equivalent to highest power of 5. Number of zeros at the end, it is equivalent to highest power of 5. Is the idea clear? Concept. Now write down, sir. Now, this something in trailing zeros we will discuss in detail, but because I am discussing factorial, I just want to give a level 1 kind of questions that will be there. Suppose, question. First one, 100 factorial ends with dash number of zeros. 100 factorial ends with dash number of zeros. 100 factorial ends with dash number of zeros. Listen carefully, sir. 100 factorial. Is it factorial? Yes. In factorial, ending with number of zeros is equivalent to power of 5. So these 5 20s are 100. 5 4s are 20. 5 4s are 20. Answer is 24. Answer is 24. Or in case if you want a traditional method, number of zeros at the end is power of 10. 10 can be written as 2 into 5 power k. So these 100, 2 how many I will get? 250s are, 225s are, 212s are, 26s are, 23s are, 21s are. 10, 20 to 47, 97. So 100 factorial, it is 2 power 97. 5 I got 24. Remaining all the power of prime numbers from 1 to 100 except 2 and 5. I want 2 into 5 power k. So 2 into 5 power 24 into 2 power 73 into k. 10 power 1 will give 1 0 at the end. 10 power 2 will give 2 zeros at the end. 10 power 24 will give you 24 zeros at the end. 24 zeros at the end. This is a method 1 and simplified version is method 2. Simplified version is method 2. For me, this problem it is not important, sir. For me, this problem it is not important. The learning from this question is important. Suppose, let me do the learning after this question. 150 factorial plus 200 factorial. 150 factorial plus 200 factorial ends with dash number of zeros. Ends with dash number of zeros. 150 factorial plus 200 factorial ends with a dash number of zeros. That is for 1 factorial. Let me do another good quality question. 150 factorial plus 200 factorial ends with a dash number of zeros. N equivalent to 150 factorial. 200 factorial can be written as 200 into 199 and so on up to 150 factorial. Am I right? So this can be written as 150 factorial 1 plus 200 into 199 into 198 and so on up to 151. Now see here, this is divisible by 5. 200 it is a multiple of 5. This is divisible by 5 plus 1. Plus 1 means whatever it is there. This is divisible by 5. It gives a number. That means the number in the bracket is not divisible by 5. Number in the bracket is not divisible by 5. Cross means not divisible by 5. Number in the bracket is not divisible by 5 because these divisible by 5. To 5 you are adding 1. To 5 multiple you are adding 1. So the number in the bracket is not divisible by 5. If a number is not divisible by 5, can it be written as 5 power into something? No. 13 is not divisible by 5. Can it be written as 5 into something? No. So no power of 5 will come. No power of 5 will come. So 150 factorial. Number of zeros at the end. For factorial, it is dependent on highest power of 5. So answer is 30 plus 6 plus 1. Answer for this question is number of zeros at the end. Answer is 37. Very, very simple question. Very, very simple question. I hope the idea it is clear. Generally in your textbooks, this will be given number of zeros at the end we have to find. This will be given. Input will be the some expression. It can contain factorial. It might not contain factorial. Number of zeros at the end. But in Anil Nair's class, we will do the reverse. Number of zeros will be given. The question input, we will find it out after this one. Now, important note. Important note. Important note. What is the number of zeros I got? 30 plus 6 plus 1, which is 37. So what is 30? First I divided 150 by 5. Yes or no? Next I divided, from where I got 6, 6 I divided, 5 5s are 25. Next I divided 150 by 5 square. Are you all with me? Next it is 1. 1 is 5 5s are 25, 25 5s are 125. Next I divided 150 by 5 cube. Whatever quotient I got, that quotient I wrote it. 25 goes 6 times. Sorry, 5 goes 30 times. 150 by 25, 6 times. 150 by 125, 1 time. Answer is 1. I hope it is clear. Instead of doing it from top to bottom, I am doing it from left to right. This is a left to right approach. This is a left to right approach. In a left to right approach, what is that I am doing? First I am dividing 150 by 5. 150 by 5, it is 30. What does these 30 denotes? There are 30 multiples of 5. What are 30 multiples of 5? 5 ones are 5, 5 twos are 10, 5 threes are 15, 5 30s are 150. Then even in the power of 25, there is a power of 5. There are 6 multiples of 25. What are 6 multiples of 25? 25 ones are 25, 25 twos are 50, 25 threes are 75, 25 6 are 150. Even power of 5. See, we are doing 5 power caser. First I did for 5 power 1, then 5 square, then 5 cube. Every highest power of 5 will also contain 150 by 125. There is one multiple of 125. So answer is 30 plus 6 plus 1. Answer is 37. 30 plus 6 plus 1. Answer is 37. So I am writing it from left to right. In our textbook, it will be written from top to bottom. We'll write it from top to bottom. Now, this is very, very important. The most important slide, sir. Very, very important key point. Very, very important key point. Extremely important key point. Listen carefully, sir. Key point. N factorial ends with x zeros, then n is greater than 4x. Please make a note of it, sir. We will see the proof also. N factorial ends with x zeros. If a factorial is ending with x zeros, then the relationship between n and x is, then n is greater than x. Then n is greater than x. Why these n greater than 4? N is greater than 4x. N is greater than 4x. Why n is greater than 4x? Proof. First, I will take an example, 100 factorial. 100 factorial ends with, listen carefully, sir. Very, very easy proof, sir. 100 factorial ends with 24 zeros. So first, what I did? 100 by 5. Next, what I did? 100 by 25. Am I right? Whatever the value, how many times it goes, that itself is the answer. 5 goes 20 times, 25 goes 4 times. I wrote the quotient. How many times 5 goes in 100? 20 times. How many times 100 goes in 25? 4 times. So it is 24 zeros. Now, 100 factorial. 100 is replaced with n. First, I will divide with 5. How much our quotient is there? That one. Then I will divide n with 5 square. How much ever it will be there? N will be dividing by 5 cube. Now, can I say here? These entire steps will stop depending upon the value of n. If the value of n is 100, it will stop at 100 by 5, 20, 100 by 25, 4, 100 by 125, it is 0, 100 by 5 power 4, it is also 0. If the value of n is 100, it is stopping at first 2 points. If the value of n is 1000, 100 by 5 possible, 100 by 25 possible, 100 by 125 possible, 100 by 625 also it is possible. It is a finite series. If n is 20, it will stop at n by 5. If n is 75, it will stop at n by 5 plus n by 5 square. If n is 200, it will stop at first 3 points. Depending upon the value of n, these series right side At after some point, every value will be 0. I hope it is clear. So can I say, if it is a finite series, 1 plus 2 plus 3, can I say that it is always less than 1 plus 2 plus 3 and so on up to infinite? A finite series, it is always less than the infinite series. X is less than n by 5, n by 5 square, n by 5 cube, and so on up to infinite. A finite value, 2 plus 4 plus 6, it is always less than 2 plus 4 plus 6 and so on up to countable infinite. I hope y equivalent to became less than. It is a finite series. It is an infinite series. A finite series is always less than infinite. A finite series is always less than infinite. So x is less than n by 5. So if I take common, this will be 1 plus 1 by 5, 1 plus 1 by 5 square, and so on. So this will be x is less than n by 5. This is an GP series, GP infinite series, GP infinite series. What is GP infinite series? A by 1 minus r. R is T2 by T1. A by 1 minus r. A is the first term. A is the first term. R is the common ratio. It can be T2 by T1 or it can be T3 by T2 and so on. So this will be x is less than n by 5 into 1 by 4 by 5. It is 5 by 4. 5 cancel. 4x less than n. N is greater than 4x. Very, very important relationship. Very, very important relationship. Make a note of very, very important slide, sir. N factorial ends with x zeros. If n factorial is ending with x zeros, what is the relationship between n and x? N is greater than 4x. It is a finite series. It will stop at a point depending upon the value of n. If n is 20, it will start at n by 5. If n is 200, it will stop at n by 5 cube. Finite series is always less than infinite series. 1 plus 2 plus 3 is always less than 1 plus 2 plus 3 and so on up to infinite. X is less than n by 5. 1 plus 1 by 5, 1 by 5 square and so on. It is a by 1 minus r. A by 1 minus r, x less than n by 5. This will be 5 by 4. 5 cancel, 4x less than n. N is greater than 4x. N is greater than 4x. I hope it is clear. By using this concept, let us solve a lot of very, very good question. N factorial ends with x zeros. Then n is greater than 4x. Very, very important key points, sir. Otherwise, you will waste a lot of time solving it. In the next two slides, let us solve some problems. First one, question. N factorial ends with 17 zeros. N factorial ends with 17 zeros. How many values n can take? How many values n can take? Question is, n factorial ends with 17 zeros. How many values n can take? What is the relationship between n and x? N is greater than 4x. X value, it is 17. N is greater than 68. N is greater than 68. In a factorial, number of zeros at the end is dependent on the power of 5. So what is the multiple of 5 greater than 68? 70. So let us see how many zeros are there. 5 14s are 70, 5 2s are 14 plus 2, 16. 70 factorial contains 16 zeros. 71 factorial also 16 zeros. So what is the next multiple of 5? 75. 5 15s are 75. 5 3s are 15. 15 plus 3, 18. From 16 zeros, there is a jump to 18 zeros. From 16 zeros, there is a jump to 18 zeros. Will I get 17 zeros? No. Answer is no value n takes. Answer is no value n exists such that n factorial ends with 17 zeros. Idea clear? N factorial ends with 17 zeros. N is greater than 4x. 4 into 17, 68. N is greater than 68. Take the multiple of 5, just greater than 68, 70. 70 contains 16 zeros. If 70 what we did, if 5 factorial contains 1 zero at the end, till the next multiple of 5, the same number of zeros will continue. 17 factorial got 16 zeros. 17 1 factorial 16 zeros. I took the next multiple. 16 zeros to 18 zeros. 17 zeros, it is not possible. Answer is no value of n exists. Suppose if the question is n factorial ends with 22 zeros. N factorial ends with 22 zeros. How many values n can take satisfying this equation? N factorial ends with 22 zeros. 22 zeros. So n will be greater than 4x. N is greater than 88. N is greater than 88. Directly you will go to that value where it is oscillating. What is the multiple of 5 just greater than 88? 90. 5 18s are 90. 5 3s are 15. 18 plus 3, it is 21. 90 factorial ends with 21 zeros, but I want 22 zeros. Let me go to the next multiple of 19. 5 19s are 95. 5 3s are 15. 19 plus 3, 22. That means 95 factorial contains 22 zeros. 95 2. What are the next numbers? 96 factorial, 97 factorial, 98 factorial, and 99 factorial. All these numbers will have 22 zeros at the end. All these numbers will have 22 zeros at the end. I hope the idea it is clear. N is greater than 4x. 4 22s are 88. What is the multiple of 5 greater than 88? 90. 90 I got 21 zeros. 95 I will get 22 zeros. So I require 21 from this number to the next multiple of 5. 100 factorial number of zeros will change. 100 factorial number of zeros will change. First question, easy question. Second one. Third one, another question. N factorial ends with 31 zeros. N factorial ends with 31 zeros. What is the maximum value n can take? N factorial ends with 31 zeros. What is the maximum value n can take? Let us see here. N is greater than 4x. N is greater than 4 into 31, which is 124. What is the multiple of 5? Just greater than 124. 125. 5 25s are 5 5s are 5 1s are 25 plus 5 plus 1. 25 plus 5 plus 1, 31 zeros. So what is the maximum value? 125 factorial will have 31 zeros. 126 factorial till 129 factorial. Till 129 factorial. 129. How much it will be? 25s are, 5 5s are, 5 1s are. So what is the maximum value n can take? Maximum value n can take will be 129. 129. I hope this concept is clear, right? Very, very easy way to understand the relationship between factorial and the number of zeros and ending with the number of zeros. N factorial ends with x zeros. The relationship is n is greater than 4x. You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free AMC.